taking fire from airplane.
Today, when we hear of the battlefield or war zones, images like these are what we are familiar with. A few years ago, in the Hindu Kush Mountains, a small U.S. Army patrol found themselves over 100 kilometers away from their base of operations. Upon realizing that they were out of communication range, they quickly found their way to higher terrain and restored line of communication. This scenario is repeated constantly in remote combat zones around the world. Radio retransmission is a common military technique used to provide long-range secure line of sight voice communications in remote and severe environments. Units establish retransmission stations by slaving together two amplified radios which function to receive any signals on one frequency within range and subsequently retransmit them on a separate frequency. The station location is often on a prominent terrain feature to ensure maximum reach, especially in areas prone to breaks in communication or dead space such as mountainous terrain. These stations can be fixed permanent structures for long-term operations or mobile temporary sites for short-term operations. The configuration of these networks that enable each radio to talk to another radio through the retransmission station or directly to one another, as in machine-to-machine applications, qualifies as a hybrid mesh network. The topology of this network is dynamic. When all radios are within range of one another in the retransmission station, the network mimics a flood topology. This requirement to accommodate constant communications and data links on a dynamic fluid battlefield sparked the development of wireless data networks exhibiting the characteristic of a true mesh topology. Each device in the network serves as a whole, as a node for transmitting its own data as well as forwarding traffic unrelated to its own functions. In the absence of an established communications infrastructure, this capability is critical to optimizing processes such as the movement of supplies toward the battlefield and casualties back to ambulance exchange points and beyond. A real-world example of a mesh network implemented in support of military operations is the Army's Combat Service Support Automated Information System Interface, CISI. These mesh networks show the value of machine-to-machine capabilities via a mesh topology in an austere environment. This is clearly not a critical system to mobile communications in the developed world. If you picked up your phone and text your bestie across the country, you could expect an instant reply. Modern communication networks rely on the fixed infrastructure consisting of interconnected cellular towers, microwave transmission, fiber optic cables. When your smartphone is likely safe from your operating system receiving an update for mesh network protocols, the future of mesh network as simple means to increase the efficiency of data transfer in mobile networks is a very real possibility. Your mobile contract should eventually include a clause permitting transmission of unrelated data via your phone in the interest of high-speed local transfer, or even volunteering participation in transmission of the emergency broadcast system, such as Amber Alerts, public safety announcements, etc. This has been a presentation of Team 4. Thank you.